Okay, now let's look at commonly used discrete probability distributions and then commonly used continuous probability distributions. We can look at the different distributions from here in at risk. If you click distributions, okay, and then select define, okay, so you're going to get a list of categories of distributions. Like if you click all, it's going to show you all the possible distributions. Continuous will give you continuous distributions, and discrete is going to give you discrete distributions. So let's not worry about the rest of them. So under discrete distribution, Bernoulli process is the most Bernoulli distribution or Bernoulli process is the most basic one. In Bernoulli process, the Bernoulli process is here any event where there are two possible outcomes, yes or no, or success or failure. The most basic example is the toss of a coin where there are two possibilities, heads or tails. Okay. So that is called Bernoulli process, and we define one of the outcomes as success, because it doesn't mean that that's a preferred outcome. It is just a terminology, and the probability of success is the parameter for Bernoulli, and we use the notation P for that. So example, whether a law will pass or not, when a candidate will get elected or not, or a drug will get approved or not, inflation will be greater than 3% or not, or inspect a product, whether the product will pass inspection or not. So all of these are examples of an event with two possible outcomes, and the probability of success is defined as P. Okay, so that distribution is just 2. So if you select that distribution, you will have 0 or 1. Okay, 1 is being success or failure, and a probability associated with that. Okay, and the default is 0.5. So if you change that to 0.8, then you see success 0.8 probability, failure 0.2 probability. Okay, so that would be the shape of the distribution, only two possible values. Now, binomial distribution is an extension of Bernoulli process. If you repeat the Bernoulli process a fixed number of times, so that's called binomial distribution. Okay. So, for example, if you're inspecting products, if you inspect one product and whether it is whether it passes inspection or not, that's Bernoulli. But if you have like 50 products and you inspect each one will result in either passing or failing, and that becomes a binomial distribution. So counting the number of successes in n trials. And the shape of the binomial distribution looks like this for p equal to 0.5. Here, well, p equal to 0.05 and n equal to 1000. So as n increases, the binomial distribution will more or less resemble the continuous probability distribution of normal distribution. So the shape is very familiar. So let's look at the possibilities here for binomial. Okay, so binomial, so 10 repetitions and 0.5 as the probability. So you change the probability to 0.05 and you see that the shape changes. Okay, now the same P of 0.05, and if you increase the number of trials to 1000 like what we had here, then we need to change the x-axis. Okay, you can right click, and instead of automatic scaling you take axis options and then change it to, so instead of automatic you click auto and then 0 through to maybe 200. Click OK, and you see that it's kind of similar to normal distribution. As n increases, okay, let's make it even closer to 100, let's say. Okay, so I have here from 30 to 70, but anyway, so you can see the normal distribution shape. So as n increases, binomial will become closer and closer to normal, and as p goes from either extreme 0 or 1 towards the middle, okay, 0.5 will give you, even for smaller n like 10, it will give you normal distribution. The shape will be very similar to normal distribution. Again, we have to change the scaling, so you see the normal distribution shape already. Okay, now we're going to look at a couple of closely related distributions to binomial, and the first one is called negative binomial. The negative binomial, instead of looking at a fixed number of trials and then counting number of successes within those n trials, we fix the number of successes we want to find and then see how many trials does it take to get to that success. Here the random variable is number of failures before a given number of success. Say you want to find 10 successes, then how many failures that we will have before we get to the desired number of success. Okay. So here x equal to n means, okay, there are n trials, we have had s minus 1 successes, and then the n plus 1 trial is a success. So that's your negative binomial. So a couple of examples: how many drive holes do we drill before we find the 5th successful well, or how many parts that we have to inspect before we find the 10th good part, or how many failures does it take in parts before we need to do a maintenance or something like that. So here is the shape of the negative binomial distribution. So let's look at that. So select a blank cell and go to define, and then under here, so negative binomial is right there. Select. So now it gives you by default 5 successes, and the probability of success is 0.5. So you have the probability distribution. So it starts from 0, okay, which would indicate that the first 5 trials were successes. So we didn't have any failures at all, and we reached 5 successes, and so on. Now we can change the probability of success. Okay, if it is like 0.2, a small number, then the number of failures before we achieve the 5 successes, it takes a lot of failures before we get to that success, and that's what we see here as p becomes small. So if it is 0.05, then it becomes something like that, and for s equal to 2, so like that. Now on the other hand, if you have a high probability of success, say 0.9, then you will see that most of the time, because the probability of success is so high, most of the time you will achieve the 2 successes even before the first failure. So 0 failures, that has the highest probability, and then down from then on. So this is called negative binomial distribution. So let's close that. So we have the negative binomial distribution inserted here. Now the next probability distribution is very closely related, is geometric distributions. In fact, it's a special case of negative binomial distribution. Geometric distribution is, instead of saying yes successes, we say the very first success. How long does it take before we get the very first success? So that distribution looks something like that. So let's try here. Okay, select a blank cell and then go to define. So now we want geometric. Okay, so here is the default p equal to 0.5. So if it is 0.5, half the time you will get the very first task or very first try is your success. So 0 is the number of failures. So if you increase higher the probability, then it becomes even taller, this bar, and smaller probabilities will result in significant probabilities for more number of trials before we achieve the very first success. So for p equal to 0.05, very small probability of success, and there are times when there are some significant probabilities where it may take 60 trials before we get to the very first success because the probability of success is so small.